We will now move on to our next presentation. Jisan Lee from With Lab, Gangneung Wonju National University, who will be presenting standardizing nursing records in K-mimic using SNOMED CT, exploring the potential for AI-human collaboration. Jisan, please go ahead.
Okay, thank you for introducing. Can you hear me? Okay, thank you. Okay, good afternoon, everyone. I'm Jisan Lee from South Korea. Now, today I want to present about the standardizing nursing record in K-mimic data set using SNOMED CT and the potential for the AI and human collaboration. Yeah. So let me briefly introduce about my background of this work. The Impact Consortium is building critical care specific and multimodal data set and is developing clinically applicable AI-based CDSS on the top of it. So our core competency is start with a large data set from the multi-center site. We plan the 24 hospital nationwide to build a single multi-center data set. But today, I will present the result of 5 hospitals. So on the challenge side, the key issue is inconsistency and ambiguity in terminology. The same clinical action is often documented in different ways across institutions. So here is a solution. As you all know, the terminology mapping. So through terminology mapping, we train the AI. Various terms refer to same clinical action. So for example, the same procedure appear with different nursing statements across hospital. As you can see, the side rail apply, raise the bedside rail, and side rail up. So in that case, the computer and CDSS cannot understand this kind of expression is the same. So we need to teach that this kind of expression have a same meaning, namely raising bedside rate to prevent fall. So this lets the system treat heterogeneous expression as a one standardized action. Here is our mapping teams. This project read by me. The mapping was conducted by team of the nurse with a hands-on ICU experience and SNOMED CT certification. So here is our brief mapping process. At the first step, we conducted independent mapping, and we have a weekly internal review and pediatric external variation. And finally, we derived the mapping table. And here is the more detailed process for map the term to the SNOMED city. So through the 5 stages, we find the most appropriate SNOMED city term. So at the first stage, we analyze the semantic basis dissections, nursing statement to the nursing term, because the nursing statement looks like a sentence, not just a word. So we need to find out the several meaning on the nursing statement. So at the first stage, we need to find the focus concept on the nursing statement. So after stage 2, we select the top level hierarchy and then find the focus concept. And the stage 4, we find the most appropriate focus concept. And then we select the correlation. Actually, we're preparing the paper on our current guideline for mapping nursing statement across multi-centers because as I know, we already have many guidelines for mapping, but I think the nursing statement from the multi-center hospital is quite complex and different with the normal ones. So we are planning the new paper about the guideline. So here of our result of mapping. So out of 20,000 items, so 57% are exact, and by the top level hierarchy, over the 50% are procedure. So this slide shows the mapping result by stage. As I told you, the local terms are mapped through the 5 stages. So before talking about the technical support for the mapping, I would like to talking about the AI training set. So we developed the data set using data from 5 hospitals, focusing on the nursing statement related to patient safety to assess the priority concept in ICU first. So as you can see, the training set contained 1,500 entities with 165 unique concepts. And for evaluating the AI, the test set has 585 entities. In total, we have 2,000 terms mapped with about 200 unique concepts. Oh, sorry. So now let's talk about our technical approach for standardization, led by Young Kim. Is the sit in there? So yeah, after human mapper established the mapping table as ground truth, the Professor Young Kim's team trained AI to assist the SNOMED CT mapping for nursing statements. It used two complementary techniques. First one is fine-tuned robot model, and second one is agentic AI. So first, the robot model, fine-tuned on the mapping table, rapidly classify the incoming nursing statement into whether the predicted concept confidence score is over the threshold or not. So this delivered high speed and moderate accuracy. Secondly, when the confidence score is lower than threshold, agentic AI use the final decision, which utilize two augmented search, file exploration, and direct query against SNOMED city for deciding a concept. So here is an example. So when nursing statement like side late apply is fitted into the fast classification robot, it outcome for prevention with a confidence score of the 0.97. So since the confidence score is higher than threshold, we consider the predicted concept as the final answer. However, when the confidence score is lower than threshold, agentic AI run, it searches the SNOMED city database to get the most appropriate concept as the final answer. As you can see, the hybrid approach merged with model-based classification and agentic AI outperforms both conventional embedding model or leg pipeline in terms of top 1 and top 5 accuracy. So our future work, we will evaluate the effectiveness of AI support from terminology mapping. So specifically, we are compare with human only versus human and AI across expert and fluent user and beginner using our grounded truth. So our primary outcome is accuracy, and secondary outcome is time to decision. So in the future, the standardized ICU terminology will enable from generalized patient classification system to more accurate workload prediction based on actual nursing intervention. And furthermore, cross-national comparison of standardized data set can meaningfully inform the development of surveillance of international clinical guidelines. So in summary, we are building the positive cycle, start with standardized nursing record and through the computable and interpretable data. So finally, we can develop the AI-based CDSS for high quality ICU care. So thank you for listening. I'm happy to take your question or comment after presentation. Thank you. Yeah. Yeah. Oh, Thank you so much.
Thank you for that excellent presentation, Jisan. As a reminder to those in the audience, if you have questions for Jisan or for any Lightning Talks presenters, please find them after the session. We will now conclude this group of Lightning Talks. The next Lightning Talks will be at 10:05 tomorrow. Please remember to visit all the exhibitors and get your passports stamped. Enjoy the expo.